Okay, so q square minus 6q sine x. Then what's next? What next we have to do? Listen again. R square is equal to p square plus q square plus 2pq cos theta. In the cos theta term, here theta is equal to, this is the angle between p, theta is angle between x, p and q. P and q, this is between these two angles. Theta I am writing as 90 plus x. So I am replacing the theta with a 90 plus x here. Cos 90 plus x will be, the values are given, r is given 6 and q is, p is given, this is a 3. And from here q square plus 2pq and q square minus q sine x. Okay, this is done, hopefully. Then let's see the next part. Tan alpha is equal to, tan alpha is equal to q sine theta upon p plus q sine, sorry, p plus q cos theta. So to do that, so tan alpha value is 90. Alpha value is 90 degrees. Then alpha is 90, then the value of it is equal to infinity. If it is infinity, what should be the case here? The denominator should be very small value. The denominator should be equal to, if it is equal to 0, then only there is infinity possible, very small value, that we consider it as a 0. Okay, very small value that is equal to, yeah. So to solve this, p plus q cos theta is equal to 90 plus x is equal to 0. P, or if I send q sin 90 cos 90 minus x is minus q sin x is equal to minus p. And yeah, so minus gets cancelled. Q sin x is equal to p. I can write this one. Q sin x is equal to p. This is the second one. Okay. Next, what we should do? So the next part, alpha part is done. So let's replace this 2 in 1. Second expression in the first expression. Then the answer would be 27 is equal to q square minus 6 into q sin x. Okay, one second. The q sin x will be equal to p. P is equal to 6 and it is 36. So q square is equal to 27 plus 36. It is equal to 63. Q square is equal to, then value of q is equal to square root of 63 meter per second. From here, even if you want, you can get the value of sin x also. Okay. Sin x is equal to, the value is p upon q. P is 6 and q is square root of 63 and x is sine inverse of 6 upon root 63. So the total angle will be, the total angle theta is equal to 90 plus sine inverse of 6 upon root 63. Okay, this is degrees. Understand? Or pi by 2 is P3. Oh, wait a minute. P3 or 6? Oh, I'm sorry, sir. P is 3. Okay, fine. I'm sorry. P is 3, then it's 6 into 3, 80. Yeah. Thank you. Yeah, q square is equal to 27 plus 18, which is equal to 45. Q is equal to square root of 45. Okay. So from here, we can write instead of square root of 63, it is sine inverse square root of 45. Okay. So 90 plus sine inverse of x. All right. There are some more things I want to explain in the class. Let's see few other examples. Okay, there are types of vectors that I forgot to explain in yesterday's class. Types of vectors. Hope you are writing all types of vectors. First one is a simple one, null vector. Everything is 0. Say a bar is equal to 0 I cap plus 0 j cap plus 0 k cap, then everything will be, yeah, everything will be 0. Yeah. So magnitude of a bar is equal to 0. Next, second is a unit vector. Unit vector. Unit vector, the magnitude of the vector is equal to, magnitude is equal to 1. Its magnitude is equal to 1. Then only it is said to be a unit vector. Okay. So then how do they find the unit vector? First write an vector P is equal to A I cap, P bar is equal to A I cap plus B j cap plus C k cap. Now mod of P bar is equal to square root of A square plus B square plus C square. If it is equal to 1, then it is equal to, then it is said to be a unit vector. Okay. Then how to calculate, how to convert a vector into a unit vector? Conversion. Converting vector into an unit vector. Okay. If to convert a vector into unit vector, just p cap, we represent with p cap, which is equal to p bar by mod of p bar. P bar by mod of p bar. P bar by mod of p bar. So let's see an example. P is equal to 2 I cap plus 3 j cap plus 5 k cap. Then convert. What is the magnitude of this? Square root of 4 plus 9, 13 plus 25, 13 plus 25, 38. Okay, but it is not equal to 1. It is not said to be a unit vector. Then what we should do? We should convert divide with the vector divided with the magnitude. So 2 I cap plus 3 j cap plus 5 k cap upon square root of 38. Then it becomes a unit vector. If you want to say how, just calculate the magnitudes here. So if you want to calculate the magnitudes again, 4 by 38 plus 9 over 38 plus 25 over 38. 38 upon 38 will be 1. Magnitude will be 1. Okay. This is the procedure. Okay. Next we shall see another, hope you wrote. So there is next one, this parallel vector. Parallel vector note down, this is a simple one. A bar is equal to I cap plus 2j cap. Next, B bar is equal to 3I cap plus 6j cap. 3I cap plus 6j cap. How can I write the B bar as? B bar as 3 common factor. I can write 3I cap plus 2j cap. What is I cap plus 2j cap? It's a bar. So we can replace 3 A bar. So B bar is equal to 3 times A bar. Okay. Yeah. 3 times A bar. So this A3 is a positive constant. Okay. If we can write B as, so take any two vectors. If any of the two vectors, if we can write B bar is equal to K times A bar. The K can be fraction, it can be integer, it can be any number, any constant. So then the K should be a positive constant. K should be a positive constant. Then this these vectors are said to be parallel vectors. These vectors are said to be parallel vectors. Okay. Then next, what shall we do? Hope you are all understanding. Parallel vectors is done. Next, anti-parallel. Anti-parallel vectors. Anti-parallel vectors, the direction will be exactly opposite to opposite to the previous one. The direction, how the direction will be opposite? The direction will be opposite. Say, an example, A bar is equal to 3I cap plus 5j cap. Okay. Next, B bar is equal to minus 6I cap minus 10j cap. Minus 6I cap minus 10j cap. Then what happens here? If you take minus 2 as a common factor, 3I cap plus 5j cap. Okay, this is a B bar. If I write a negative, if we can't multiply it with a negative, say positive plus I cap minus plus j cap, it's in a first quadrant. Minus is minus I cap minus j cap is in a third quadrant. The answer, and yeah, this if B bar is equal to minus K times, can be expressed as B bar is equal to minus K times A bar. If it is represented like this, then where K is a positive constant, there is a positive constant, then these vectors are called antiparallel vectors. Okay. Then next we proceed further. Sir, we can take ratios and check whether the parallel or not, sir. Ratios, what ratios you'll check? Can you divide the vectors directly? Okay, we can take out the common factors first. Take out the common factors and then you see. Common factors means from 6i minus 10j, you can take out the 2 as a common factor. That's why you can find it. So direct division of the vectors is not there. Directly we cannot divide. Okay, next. Sir, but k is a negative minus 2, which is a negative. Then how, sir? K is a negative. Let's write simple equations. I cap, how it will be 2i cap, it is in the right direction. Minus 3i cap, what happens? The minus multiplies, the direction will change and the magnitude will be one time more than this. 3i cap minus 3. The directions are changed. That's how it represents. Okay. Okay, fine. So let's see one more example. Some other example for coplanar vectors. Coplanar vectors. Coplanar vectors. If all the vectors on the same plane, if all the vectors on same plane, then these vectors are said to be coplanar vectors. Okay. So if all the vectors on the same plane, then these vectors are said to be a coplanar vectors. What are the examples? Examples, sir. The planes, we have expressions y direction, so this is y-axis and this is x-axis. What plane it is? This entire expression, what sort of plane? This is y-x plane. Y-x plane. Instead of y-x, there is one more plane, which is I will send the record lecture in the group. Don't worry. First concentrate on the class. This is y and z. This is a different plane. Two different planes. Say vectors. The vectors names are A, B, and C vectors. And here, in the other fellow, so there are different vectors. C, D, E, F. Now, our question is, this A, B, C, these three vectors comes under the same plane because it is in a y-x plane. So these are all three vectors are called coplanar vectors. Coplanar vectors because they are on a same plane. Okay, and this is EDF. They are on a same plane. Is called coplanar vectors. This is actually a two-dimensional part. Yes, it is three-dimensional, sir, but three-dimensional cases, plane comes to two-dimensionally. Plane doesn't come in a three-dimensional part. Okay, plane comes in a two-dimensional part. Then we can different directions we go. There will be three dimensions. Plane means if you take a cube, a plane comes in a one direction, so two axes only. Not more than that. Okay. If all the vectors comes in the same plane, so these are all called coplanar vectors. Note down. This is done. Coplanar vectors. Seema, plane means only two vectors should be there. Two axes should be there. Must we have two axes? Only two axes, not more than that or less. Non-coplanar, that's all. If the vectors are not planar, not in the same plane, they are not coplanar vectors. Next, we shall see dot product today. So these are the introduction of the certain things. Let's see the dot product. Okay, did I say anything about orthogonal vectors? Okay, I will discuss that in dot product only. So dot product of the vectors. Say a vector, the representation is a bar dot b bar, which is equal to a bar dot b bar, which is equal to mod of a mod of b cos theta, mod of a mod of b cos theta. Okay. What is a mod a? Is a magnitude of a, magnitude of b, and the theta is angle between a and b. Theta is angle between a and b. Okay. Yes. The way to do the dot product. Let's say an example. A bar is equal to a I cap plus b j cap plus c k cap. B bar is equal to x I cap plus y j cap plus z k cap. The dot product notations are, it follows as it is, like I cap dot I cap is equal to 1, j cap dot j cap is equal to 1, k cap dot k cap is equal to 1. Remaining all other cases, it is equal to 0. Remain all other cases, the values are 0, which means like I cap dot j cap is equal to 0, I cap dot k cap is equal to 0. Okay. And j cap dot j cap. So first listen, then I will explain why dot product we have to do. What is the reason? We'll find all these things. Don't worry. Don't worry. This I will explain. First, as of now, you follow this. I will explain why it is. Okay. So this is j cap dot I cap. Everything else is 0. K cap dot I cap. Everything becomes 0. Okay. So let's do the dot product. The way to do the dot product. Hold on quickly. A bar dot b bar. A bar is equal to E plus b j cap plus plus c k cap dot x I cap plus y j cap plus z k cap. The dot product, first a I and I and I, it is equal to 1. So constants are there before I, a, and before I, x. So the value will be a into x plus ij would be 0, I, k would be 0. And the remaining b, and so remaining thing, what we should do, only I multiplied with I, j multiplied with j, k multiplied with k, that one. I, a, x, next b, y plus c, z. Now the answer we got, We'll see examples also. Now, ax, by, bx plus by plus cz. All these cases, this is a vector form or scalar form. Ax plus by plus cz. Are there any I, j, k terms? This is a scalar form. There are no other i's, j's and k's. So this is a completely scalar form. So this is a scalar form. So dot product of the two vectors is a scalar. Dot product of two vectors is a scalar. Okay. Quick. Sir, why we have to do the dot product? Why it is coming as a constant? So listen. Next, dot product of the two vectors is a scalar. That's we proved. Let's physically represent what the scalar product indicate. What is this? Is dot product is also called scalar product. So scalar product. Yeah. Now, this is a vector. There is an angle theta here. There is a b vector. Magnitude of b vector is b. I'm writing instead of vector form, I'm writing this directly as a scalar. Okay. This is b. This is a. Now, we have seen a bar dot b bar is equal to mod a mod b cos theta. Mod a mod b cos theta. Then what will be the b cos theta? B cos theta is the projection of b on a. So this will be projection of b on a. It will be this value. If we project b, this is how b cos theta. B cos theta is called projection of b vector on a vector. Projection of b vector on a vector. Then the value. So this is equal to b cos theta, right? So sometimes they don't give b cos theta. They will give vectors. Then what we should do? A bar dot b bar is equal to mod a mod b cos theta. Then b cos theta will be equal to a bar dot b bar by mod a. So this is the formula for projection of b. Projection of b vector on a vector. Projection of b vector on a vector. Next, projection of okay, done. I will draw this diagram again. Let's see another part. A, P. There is an angle theta. Okay. So now we are just converting. I'm just turning up the vectors A, B. Okay. So for you to understand, this is A, and this part is B, and this fellow doesn't go. There is an angle A vector, B vector. There is an angle theta. A vector, B vector, and there is an angle theta. What is the projection of A on B? Projection of A on B, just directly draw a line. What is the value of projection of A on B? This length will be a projection of A on B. Okay, the value of this will be A cos theta. Will be A cos theta. A cos theta. So to explain again, so listen again. There is a vector and a B vector. So to substitute the values, say now I am projecting A on B. I am projecting A over B. So if I project, what will be the distance from here to here? This will be, the value will be, here is an angle theta, the magnitude is A, it will be A cos theta, which means projection of A vector on B is A cos theta. A cos theta. As per the previous discussion, to find this, we have A bar dot B bar is equal to mod A mod B cos theta. To get A cos theta, A cos theta, which is equal to A bar dot B bar upon mod B. So this is a formula for projection of A on a vector B. Projection of A on a vector B. Did you get this? Okay, I'm done. Let's see other part. So is my voice is breaking? Is it breaking or not? It's not breaking, right? Thank you. Okay. So let's see the other part of the section. If it's breaking, then check your net connection. I recently changed my connection to upgraded net connection. So there will be no data interruption from my side. Okay. So let's see the other part. Okay, some students asked, what about b bar dot a bar, sir? B bar dot a bar is equal to how much, sir? A bar we got. B bar, what is the formula? X I cap plus y j cap plus z k cap. B. A is a I cap plus b j cap plus c k cap. A b bar dot a bar. B bar dot a bar, which is equal to ax I and I component multiplied with I component. Ax plus b component. Sorry, y component. Yb plus cz. So b bar dot a bar, both are same. So a bar dot b bar is equal to b bar dot a bar. A bar, yeah. Whatever rule you see. Hmm. Now, let's see further part. Some examples. Hmm. The examples are a bar is equal to 2 I cap plus 3j cap. B bar is equal to a, okay, simple question I'll ask. 3 I cap plus 4j cap. Find angle between them. Find the angle between these two vectors. Yes, cumulative. No, 90 or 180 is wrong answer. Okay. Yeah. So simple. It is equal to mod a bar dot b bar is 3 and 2, 3, 6. 6 plus 12 is equal to, so a bar dot b bar. To get an angle, whenever they ask you find the angle, first we need to do the dot product. Dot product a bar dot b bar is equal to mod a mod b cos theta. From here, we can get an angle between the two vectors. A bar b is equal to 6 plus 12, 18. Oh, is equal to a is square root of 13, b is square root of 25 cos theta. It is equal to cos theta is equal to 18 upon 5 root 13. This is the answer. Theta will get from here. Okay. So a bar dot b, 2 multiplied with 3, 6, and 4 multiplied with 3, 12. So if you add 6 plus 12 here, it is equal to 18. A bar dot b bar. Okay. So let's see another question. A bar is equal to a I cap plus 3j cap plus 4k cap. B is equal to 2i cap minus 6j cap plus 4k cap. If a bar and b bar are perpendicular or orthogonal to each other, or perpendicular, handwriting both are perpendicular to each other. If a and b are perpendicular, find small a. A is equal to how much? Very good. So if they are perpendicular to each other, that's nothing but orthogonal. If they are orthogonal, the cos theta is 90 degrees. Cos 90 is equal to 0. And here, yeah, cos 90 is equal to 0. A bar dot b bar. First, write a bar dot b bar is equal to ab cos theta. So 2a minus 18 plus 16. 2a minus 18 plus 16 is equal to cos 90 0. A is equal to 1. हो गया इसका सिग्मा 17. A is equal to 1. One more question I want to ask. Certain questions from the vectors. Shall I ask from the vectors? Okay. Okay. So note down the question. A body is doing a circular motion. Circular motion with constant velocity. Circular motion with constant velocity. Okay. And initially it was at the lowest point, and afterwards it moved to a point where it's making an angle. Move to a point where it's making an angle 60 degrees. Here is an angle 60 degrees. Initial position, lowest point, and this is B. Find, so body is moving with the constant velocity, right? Previous question somebody is asking. From the lowest point, it has moved to B. Find, so body is doing constant circular motion with constant velocity. With constant velocity. Find the change in velocity between the positions B and A. Find the change in velocity between the positions A and B. Okay, ma. Listen this part carefully. Sir, you said velocity is a constant. Subtraction will be 0, na sir? So listen carefully. At the lowest point, velocities, how the velocity will be at the lowest point. At the lowest point, the velocity is like a tangent. Circular motion, you know, right? In circular motion, if a body is at the circular path, the velocity will be tangential. At the lowest point, this is V bar. Okay, so V1, I'm just keeping V1 in one direction. After 60 degrees, it is making an angle 60 degrees. Okay, 60 degrees there, and the velocity is V. Velocity is V. Now, here is an angle 60 degrees, and okay, here it will be 30 degrees, here it will be 60 degrees, 30 degrees, and here will be 60 degrees. Are you all understood? Shall I explain again? Here it will be 60 degrees. Okay, and the other end it will also be 60 degrees. Okay, now V2, this are velocity is a vector. So this is axis, x and y axis. Okay, x axis and y axis. We should write in our representation notations properly. V1 is equal to, it is initially it is moving with the horizontal direction. Very good. It is V I cap. V1 is equal to V I cap. After that, it's going with a velocity V and making an angle 60 degrees. V2 bar, we should write, this is a vector notation. V2 bar is equal to, write in a vector, horizontal and vertical components. If I write the components, it will be V cos 60 I cap and V sin 60 j cap. Let's write that. V2 bar is equal to, okay, so V cos 60 I cap plus V sin 60 j cap. Okay, hope you are doing nice. Cos 60 is equal to V upon 2 I cap plus sin 60 is root 3 upon 2 V j cap. This is V2 bar. Okay, V2 bar minus V1 bar. This is what the subtraction is. V2 bar minus V1 bar, if you do, not understood. So listen carefully again. Listen, ma. Vector, velocity is a scalar or vector? Tell me first. Velocity is a vector. If velocity is a vector, then we need to do vector subtraction. We cannot directly subtract the things. Okay, how did you get V2? So V2 this is the velocity V, and here it is making with an x-axis 60 degrees, right? If it is making 60 degrees, resolve into components. If resolve into components, then V cos 60 is x component, V sin 60 will be the y component. Okay, that's what we wrote, V cos 60. Even if velocity is constant, velocity is a vector. Okay, we discussed one thing. If velocity should be, if it is in the same direction and if it is moving in the same direction with same velocity, same magnitude, then change in velocity is 0. If it is moving in the same direction in the same magnitude, then change in velocity is 0. Okay, if it's moving with the same magnitude but the direction is different, then it's not 0. If it is moving in different directions with same magnitude, the change in velocity is not equal to 0. All right. So v over 2. So v2 minus v1. If we substitute here, yeah, v2 bar, v2 v by 2 I cap plus root 3 by 2 v j cap minus v I cap minus v I cap. Okay. Anything you do, no problem. v2 minus v1 or change in velocity is what we'll do. Final velocity minus initial velocity or initial minus v1 is final velocity. Final velocity minus initial velocity. So if we substitute here, minus v upon 2 I cap plus root 3 upon 2 v j cap. So okay, this is not a magnitude. Magnitude will be the magnitude will be magnitude of v2 bar minus v1 bar is equal to square root of v upon 2 whole square plus 3 4 v whole square. Okay, 3 4 v square. Okay, the answer will be it is equal to v. So delta v bar is equal to v meter per second. This is the answer. Okay, madam. Sir, should we always show answer in magnitudes? No need not be. If answer, see, if they're asking for magnitude alone, if they're asking for magnitude alone, you need to write in a magnitude form. If they're asking for a vector form, you need to write in a vector form. Okay. Anything? Oh, I forgot to explain. So this is a vector subtraction. Array. Some example applications on dot product I forgot. So applications on dot product. What is the time? 3:15. Okay. So note down the next question. Two vectors Next example. Two forces acting on a body and sum of the forces is 12 Newton, 12 Newton, and the resultant of two forces is 18 Newton, and the resultant is making an angle. Resultant is perpendicular to the smaller force. Perpendicular to the smaller force. Find the two forces. Find the two forces. Wait. Change the values. 12 you keep here, 18 you change here. Okay, ma'am, sorry, this is some correct. Mm-hmm. 10 and 8. Okay. Some others. Can you check your answer again? Okay. Let me explain this. 2 minutes. Huh? Okay. Okay. See the question and then we'll start doing the problem. Okay. So I understand there is one concept I did not. Very good. One person. Akash. Correct. It's not 3. It's square root of 3. Okay. So now resultant of the two vectors, unit vectors. R square is equal to P square plus Q square plus 2PQ. So I am Akash. Oh, okay, fine. I'll call you to only Akash. Okay. Cos theta. P, and he's saying that unit vectors, the resultant, the unit vectors are P is equal to Q is equal to 1, and he is saying the resultant also 1. R is also equal to 1. So 1 is equal to 1 plus 2 cos theta. 1, 1, 0. Cos theta is equal to minus 1 by 2. And the theta is equal to 120 degrees. Theta is equal to 120 degrees. Yes. Vector addition. So when there is an addition, the formula R square is equal to, when there is an addition of the vectors, R square is equal to P square plus Q square plus 2PQ cos theta. When there is a subtraction of the vectors, R square is equal to P square plus Q square minus 2PQ cos theta. Okay. So cos theta, theta is 120 degrees, it's minus 1 upon 2. And r square is equal to 1 plus 1 minus 1, 2 cos 1 by 2 minus 1 by 2. So 2 gets cancelled. And r is equal to square root of 3. Subtraction of the vectors. All right? Very good. Almost all of you got the answer. Akshaj, okay. I'm sorry, I read your name in wrong way. Akshaj, okay. Got it? Fine. So, see here. First, we got a unit vectors 2r. So, P, Q, R all are equal to 1 because this is a unit vector. P, Q, R everything is equal to 1. So, from there, if you substitute P values, R values, Q values, so 2 cos theta is equal to minus 1 will get cos theta is equal to minus 1 upon 2, is equal to 120 degrees. Okay. And last, addition is equal to, addition formula is plus 2pq cos theta, and subtraction is minus 2pq cos theta. Okay. And resultant is square root of 3. So this is the formula for, if you substitute cos theta value, minus minus becomes plus, r will be root 3. Is it understandable? Okay. Certain applications on dot product. So I'll end with this. Applications on dot product. How we should apply dot products. Because subtraction will be minus theta, then you understand that part. So applications of dot product. The dot product is used for finding the work done. Find work done. Work done formula W is equal to F bar dot S bar. S bar 9, I should write delta R bar. If I write, it will be more appropriate. F bar delta R bar is nothing but displacement. Delta R bar is nothing but displacement. And F bar is force. Delta F bar is force. So if they ask directly, they will give displacement, or they will give initial and final positions of body. Initially, at R1 is equal to R1 bar is equal to A I cap plus B J cap. After certain time, R2 bar is equal to X plus Y J cap. The force acting is equal to F1 I cap plus F2 J cap. Then what is the work done? What we need to do? First, F bar dot delta R bar. Delta R bar is nothing but R2 bar minus R1 bar. R2 bar minus R1 bar. Here is R2 bar and minus R1 bar. And R2 is nothing but X minus Y, A I cap plus Y minus B J cap. This is delta R bar. Okay. So work done is equal to F is F1 I cap plus F2 J cap dot X minus A I cap plus Y minus B J cap. Okay. Simplify this, your answer is done. Yes, very good. power. This is one of the applications work done. And the next one is also power. Power is equal to, yeah, better to write in exact terms, it's instantaneous power. F bar power is equal to the formula P is equal to F bar dot V bar, where F bar is a force vector, V bar is a velocity vector. These are the two examples that comes to my mind. So to calculate the instant power and velocity power, okay, power P is not so proper here. F bar dot V bar. Okay, ma? Sir, when crossword, we'll discuss in the next class. Okay? Okay, ma. Thank you very much. So tomorrow, next class, we'll see. Okay? Bye. Okay, there.